All right, we've been working with graphing equations. So graphing them and then finding the slope of the lines that we have. So you guys have been taking equations such as y equals 2x plus 1. And when I asked you to graph them, you were making a data table of values. So you have to go through and you're picking numbers to put in here for x. And then you're solving that to get the y value. So if I plug a 0 in here for x, I'm going to have 2 times 0 plus 1, which is 1. This one would be 3. This one would be 5 and 7. Then you are going through and you're having to graph it. Then I'm asking you to find the slope. So all these different things that I'm asking you to do. And you're probably wondering, there has got to be a simpler way, a way that's maybe not as like time consuming. And there is. So there's something I want you to notice here. So I could fill out this data table, take all these points, and I could graph them. So 0, 1, 1, 3, 2, 5, 3, 7. And I could graph this. If I wanted to find this slope, I could count. So I would say that my slope is up 2 over 1 for a slope of 2 over 1. Or I could have used my data table and I could have found here that this is a difference of 2 and 1 every time. And again, I would have came up with a slope of 2 over 1. But there's something else I really want you to notice here. Where else do you see a 2 over 1 or just a 2? So where else do you see that number at? And I'm hoping that when you think about it, you start looking at it, you'll start to notice that it's up here in the equation, that is a 2. And there's another characteristic of the graph that you're going to have to kind of start identifying, and that is what we call the y-intercept. So the y-intercept is where the line crosses the y-axis. So where at on this line does the line that we graphed cross the y-axis? Well, for this one, it's this point right here. And that would be the coordinate of 0, 1. X always has to be, so I'm going to write this down because it's really important. X always has to equal 0 for the y-intercept. So whenever it crosses that y-axis, x has to equal 0. It's the only way for it to go across that axis. So that equals 0. And I'm kind of hoping that you're going to notice that this right here, this 1, is also somewhere else. And I'm really hoping that you're going to look back up here at that equation and notice that it's right here in the equation as well. So everything that I'm going to ask you to do and get now, like the slope and the y-intercept, are going to come from our equation. And they're able to come from our equations because this is what we call a slope-intercept form. So your equation, when you get it into y equals format, is called a slope-intercept form. So that's the format that you are solving for these problems to get into. So slope-intercept form. This is slope-intercept. And there's a reason why it's called that. So slope-intercept is called that because from this equation, I can find the slope and your y-intercept just from looking at it. You don't even have to graph. You don't have to plug values in. You don't have to do anything. As long as it's in that y equals format, you will be able to find the slope and the y-intercept. So right here, this m is what stands for our slope. So anytime you have an equation, so for instance, y equals 2/3 x plus 5, the number that is attached to the x right here is what your slope is going to be. So even if it was in the format of y equals 5 plus 2/3 x, this 2/3 is connected to the x. They're just in a different spot. And that's okay too. You can always have b plus mx, or or even b minus mx. It's not going to always be positive. Anyway, the number that is always connected to that x is what your slope is. Now the y-intercept is what is in that b spot. So for instance, here in this equation over here, that 5 is all by itself, it's at the end, that's what our y-intercept is. Same thing here, it's going to be that 5. So what this tells me is that I'm going to be able to graph this equation without even making a data table. I'm going to rewrite it up here. Without making a data table, without plugging in values, without doing much work. And here's how this is going to start. You will always start at the point that you know. So what do I know? Let's figure this out first. So I have my slope and I can get my y-intercept because this equation is in y equals. So what would my slope be? Well, it's that number that is attached to the x. It is not the x, it's just the number that's with it. So my slope is going to be 2/3. Now my y-intercept. My y-intercept is what is that number that's not attached to my variable, kind of by itself. That would be my y-intercept. And remember just, 30 seconds ago, I said x has to equal something for this to be my y-intercept. And x has to equal 0. So could I put this on my graph? Since I know x would equal 0 for it to cross that y-axis, that line is going to cross the y-axis at 5. So couldn't I put that on my graph? So I'm here and I'm going to go up 1, 2, 3, 4, 5, and I'm going to put my dot there because it tells me this line is going to cross the y-axis at 5. So start it there. So the first step in graphing an equation without making a data table is to find the y-intercept, and I'm going to also mark on here B, so B, and plot it. So find the y-intercept and plot it, which I just did. I plotted that 5. So the next step is going to be using our slope. You guys know that for a slope from a graph, it's rise over run, it's y over x, it's that change in y over change in x. And to find the slope, we simply count. Well, I'm going to tell you now for your next point on your graph, all you have to do is count. However, you have to know those rules, those signs. So going up is positive, going down is negative, to the right is positive, to the left is negative. So I know that both of these numbers are positive, so my slope is going to look like this. So I'm going to start at my y-intercept at this 5. I'm going to change the color so you can see me moving it with me. So I'm going to start here at this 5, and I'm going to count up 2. So 1, 2, and then I'm going to count over 3. So 1, 2, 3. My next point is going to be right there. Now, I'm going to erase those little black ones because those don't need to be on there. Okay. So now I'm going to do it again because I want more points on my graph than just 2, although you don't have to. I'm going to start here now. I'm going to go up 1, 2, over 3, 1, 2, 3. There's my next point, and I've got my line. So I was just able to graph this equation without making a data table and without finding values and plugging anything in. I was able to do it just by looking at that equation. So let's try another one. If I have the problem y minus 1 equals negative 2/3 x. Okay, so the first thing I need to know here is that I have got to have it in that slope-intercept form. So it's going to be y equals mx plus b. I do not have it in y-intercept form yet, slope-intercept form yet. Because y is not by itself. So the first thing I'm going to have to do is move this -1. Pretty easy since we know how to do this already. I am just going to rewrite this to have y by itself. And I've got negative 2/3 x plus 1 now. Now it looks just like this. It is in slope-intercept form. So my slope is going to be negative 2/3, and I'm going to just write it below what they represent, and my y-intercept is going to be a positive 1. All right, now this tells me then that I can graph this just by using those two numbers for my graph. So the first thing I'm going to do is start with my y-intercept. My y-intercept is 1, so I'm going to go to my y-axis and put my dot on 1. And there I am. There's my first dot. I already have half my graph done. Now I'm going to use my slope. Now this is a negative, so I've got to make this choice. You guys know this. If you have two negatives, it equals a positive. So for a negative slope, I've got to pick which number I want to be negative. It either has to be the top number, so for a negative slope, I'm either going to go down and then to the right, or I'm going to go up and I'm going to go to the left. Because only one of my moves can be negative. If I make two negative moves, it's going to end up being a positive slope. Two negatives make a positive. Okay, so I only want one of these to be negative. I'm going to choose the 3 to be negative. I just like to work going up. So I'm going to go up 2. So I'm going to use this right here for my slope. I'm going to go up 2, and then I'm going to go to the left 3. 1, 2, 3. There's my next point on my graph. So then I'm going to do it again. 1, 2, 1, 2, 3. There's my next point. There we go. So I was able to just graph 4 points on my graph. I know that this is a negative slope because when I start to read it, I'm reading it from here and it is dropping down. So I know that I got it right because it's that negative. And I was able to do that without creating a data table. Okay, so if I asked you, let's find the slope. What would the slope and the y-intercept be of this equation? You would be able to tell me just by looking at this problem. The slope is the one that is connected to that x, so my slope would be 5. My y-intercept is the number that's by itself. That would be negative 4. And you would be done. You don't have to graph it any other way. That is all you would have to do is to graph it, find the slope, that y-intercept, and then use those points to create your graph.